So they give us this region R in the first quadrant. This one's a little strange though, they split it, it's a piecewise function. So from 0 to 1, our graph is 2 minus x squared, and I'll just write that a little bit bigger because it's kind of small. So 2 minus x squared for this first part, so from 0 to 1, and then it is x minus 2 squared from 1 to 2. I'll write that a little bigger, but actually also let me multiply that out. If you have x minus 2 squared, that's going to be x squared minus 4x plus 4. All right, so those are the two functions. The first one's from 0 to 1. The second one is from 1 to 2. All right, so letter A, find the area of R. So you would think like okay, well, integral from 0 to 2. We're just going to have to break it at 1 because that's where the function breaks. So we're going to do integral from 0 to 1 of the first function. So it's just going to be like a two-part problem, basically. And then add on the integral from 1 to 2 for the second function. So we're just finding the area under the curve. We had to break it right here is what happened. All right, so antiderivative. We're going to do this as like a part A and a part B. Antiderivative here would be 2x minus 1/3 x cubed from 0 to 1. And then the second one, this antiderivative, 1/3 x cubed minus 2x squared plus 4x, and then from 1 to 2. Now it's free response, so we're not going to have to actually evaluate any of this. We just have to do upper boundary minus lower boundary. This one, if you plug in 1, you're going to get 2 minus 1/3. And then it would be minus nothing. You could put minus 0 if you want or not. Plugging in 0 for all those x's is just going to give you 0. All right, plus, and then we're going to do upper boundary. 2 cubed is 8, so this will be 8/3 minus 2 squared is 4, double that is 8. And then 2 times 4 is 8. And then minus lower boundary, plugging in the 1 would give us 1/3 minus 2 plus 4. And then stop, do nothing to that, because if you mess any of it up, then it's going to be wrong. This was upper boundary minus lower boundary for the first one, and then this was upper boundary minus lower boundary for the second one. So it's just a two-part problem. That wasn't so bad. The functions, at least, were easy to deal with. We didn't have like an arc sign or anything weird. All right, letter B. This is going to be a cross-section one. You have to imagine these shapes popping up out of the paper at you. Region R is the base of the solid. For the solid, each cross-section perpendicular to the x-axis, so it'll be a dx problem, is a square. Now, the thing is, we have two squares, one for the first part, one for the second part. Again, they broke this at 1 because it's defined by a piecewise function. So we're going to have two separate squares. For the first one, the base of our square is going to be this graph, the 2 minus x squared. And then for the second half of it, from 1 to 2, it's going to be this. All right, so again, it's going to be a two-part problem. We're going to have to do from 0 to 1 and then from 1 to 2. So we'll go from 0 to 1, and then you have to put the area of your shape in there. So for a square, it's going to be this times itself. So 2 minus x squared squared dx. And then same thing from 1 to 2, we want the area of this square, which is going to be this stuff times itself. And all they ask us to do is set this up. It says write, but do not evaluate an expression involving integrals. So this is your answer, and you don't have to do anything to that, which is very nice. All right, and then C, the portion of the region are from 1 to 2. Okay, so we're only going to look at from 1 to 2 now. So we're only looking at this part. So we're not going to have to break this into two separate problems. We're only looking at this area now. Is revolved around the y-axis to form a solid, find the volume. All right, so we're going to spin this around the y-axis. I'm going to draw my ghost shape over here. And this is going to be our outside circle and then our inside circle. So let's think about what this one would look like. It would be kind of like a funnel on the outside and then this gigantic hole through the middle. So I guess like a funnel that has like a really large opening in it. So you spin this around, it's going to be round, and then you'll have, you know, this gap in the middle. Right. So since it's going to be a dy problem, we need to rearrange the equation. I'm going to use this version of it, the x minus 2 squared. That's going to be easier to manipulate. Let me write that off to the side here. We have y equals x minus 2 squared. We have to get x by itself for that one. We have to rearrange it. So we're going to square root and then add over the 2. So this is the equation that we're going to be using. So setting it up, it's going to be pi r squared minus r squared dy. Again, dy because we're going around the y-axis. And so let's go and get our boundaries. I know it's like you want to go 0 to 2, but remember, we're not using this part of the graph now. We're only using this section. So it's going to be from 0 to 1 for our boundaries. So 0 to 1, and I'm writing that. I don't want to keep sliding the paper up and down and make you guys seasick. I'll move it down once I'm ready to work on the whole problem. Here's your outside radius. So it'll be right graph minus left graph. So the right graph is that curve. The left graph is the y-axis. So it'll be that 2 plus square root of y we got. And then inside radius is going to be 1 minus 0, which is just 1. Or you can look at this and go, oh, that distance is 1 unit. So that's just going to be 1. So again, the boundaries were 0 to 1. The outer radius was this curve minus nothing. And then the inner radius was just 1. Now this one we do have to actually work out. So if you multiply this out, and if you want to write off to the side 2 plus square root of y times 2 plus square root of y, we're going to distribute all of that to each other. So 2 times 2 is 4. The outsides give you 2 square root, insides give you 2 square root. So that's 4 square root of y. And then square root of y times square root of y is just y. And then we're going to have minus 1. And then dy. I'm going to take a step and clean some of this up a little bit before I do the antiderivative. First of all, 4 minus 1 is just going to give you 3. And then I'm going to rewrite this. I'll throw this question at you guys. What exponent is this going to be for a square root? It would be y to the what? Good, nice job, guys. Perfect, 1/2. When you go to do the antiderivative, it's just better for it to be written that way. All right, so y to the 1/2 and then plus 1 dy. All right, so antiderivative is going to be 3y. Now here you have to add 1 to the power, so that'll be y to the 3/2, and then you would want a 2/3 out front. So 4 times 2 would be 8, so 8/3. Again, it would be a 2/3, but there's already a 4 there. So 4 times 2 gives you 8, so 8/3. And then plus 1/2 y squared, evaluated from 0 to 1. And all you have to do is plug in 1, because again, 0 for all these is just going to make all that 0. And it's free response, so you don't need to simplify any of this. It'll just be 3 plus 8/3 plus 1/2.